Yeah, so this is going to be a walkthrough for the exercise 03, which has to do with something called Monte Carlo simulation. We are not going to talk about what Monte Carlo simulation is, but we are going to use this method to find an approximation for the number pi. So if you look at the assignment here, so the purpose here is to program a function. So what we're going to do is to program a function as a program, which is a function without inputs and outputs. We did that also in exercise 2, and then it's again, create a user data block, use a function call with arguments. We've basically done that too in exercise 2. Call this function using data block variables and so on, and learn the what we call iterative nature of the PLC program. That the PLC program, the one we are using, is executing, and then when it's done with the whatever you put in the program, it just restarts and executes all the time. So it's a perpetual loop basically. In high-level language programming, when you start out, you make a perpetual loop in your program. You write something like while true or something, and then the program you make is just running inside there until your PC program stops, or you just abort the program. So that's basically what the task in our PLC CPU does. Okay, yeah, the PLC simulator and so on. Avoid function, we are just call it program Monte Carlo pi, and call it in the program main, and yeah, and documentation is to hand in this. So here's the assignment and handed in, and here is the background Monte Carlo simulation. There are some links down here, so you can read a little bit about what Monte Carlo simulation is. But basically, what this document says is that we generate two random numbers between 0 and 1. It's important that they are between 0 and 1. And then we use Pythagoras to calculate this diagonal here, or yes, the diagonal for the circle is basically what we do. But it's the hypotenuse, whatever. In the triangle here, hypotenuse, whatever, which of course can, if I calculate that, if my random numbers are 1 and 1, I'm going to end up here. If I get a number below 0, no, below 1, I mean, it's going to end up inside this circle here. So what I'm doing is that I'm generating a lot of random numbers. That's what I want to do. Calculate this, the radius for the circle, basically what I do. So if that's less than 1, I just increment one number, and then for all of the numbers, for every iteration I do, I just increment another number. So that's down here. And then I use this the property between the areas here, the area of the circle and the area up here, and then just divide those through. That should be pi fourth, this one. And so when I do this, I just have to multiply by 4 to get pi, and then I have an estimation for pi. The easiest way to get the number pi in a PLC. But this is just to make our program, and what we say up here is to clearly demonstrate this iterative nature of a PLC program, or the PLC program we are using. Yes, and down here there's let's say what we call a pseudocode algorithm, which is implementing this one. The square root here is this one, and so on. And here is what the result is inside the square here. Yes, it's inside a square. And then we also check if it's inside the circle here. Is it that? Then we assign. Here should be an equal sign, but that's not that important. then we increment another number. And when we are done, or not done, then we all the time we just calculate pi based on these two numbers and see that should be 3.14 or something, at least close to that. What the rest of the document says, that you need a pseudo or a random number generator that's kind of good, and here's one that's used a bit, this algorithm here, and this function that you are going to use in the library is using this algorithm here. It returns, if you want to get a really exact estimate for pi, this one has to be really random. But we can see how many decimals we get out of the estimations here. Yes, and this is also a programming tips to how to do this. So here's the data block, and this random number function needs a seed like this. That's always update, and this information that's in here, those are two prime numbers, one for each of the random function, and as the random function is called, this one is changed and calculate a new random number and does something internal to scale that random number between 0 to 1. So this is what it says is basically this, no, not that one, this pseudo code down here, but it's not a loop here. So what we are going to do is to say, okay, if this execute Monte Carlo simulation is not true, we are not going to do something, we're just going to stop. If you have calculated a number for pi and we stop, okay, that's the number, we are going to freeze it. When you look at the solution for this exercise, we're going to see how that works. Two calls to the random function with starting seed, there should be a t in here. Then those are these two seeds, and then we have to return the number here, and then we calculate the radius. We have to use the square root and square for this. So we have to square the random numbers and add them, the squares, and then we have to take the square root of this. But square root, we saw that one in the last exercise, the built-in function. Yeah, there's not much to calculate the approximation for number pi. It should have this one. That's the last one that we are calculating. And remember, this is a function. We just call it program. That's going to return nothing. So we need everything in a user data block. So this data block is just a suggestion what you should could do. So if we look quick at the exercise down in the portal, this is the one that you are going to program, and this is the data block that was in the programming tips, and the random function is up here. So you have to find out how to call a function with an argument. That should be in the last exercise, so it shouldn't be this difficult, but then you have to implement the code. So this was a quick walkthrough for the exercise. What you have to do is you in TI portal, you should make a program that we call program Monte Carlo pi, and you should enter the code according to programming tips, and call that in this in program main. I didn't say that earlier, and test it on the emulator. So that's it's the sign.